All right, everyone, welcome to section 1.3. We're just going to get started. We're going to start talking about the derivative and specifically some rules about the derivative. So first off, and we heavily implied this, I may have even said it in 1.2, which was yesterday for me. I don't know what day it was for you, but here's one of the most important things of the entire section, of the entire class maybe. All right. The derivative f prime of x is just the slope formula from before. Okay, so the derivative just gives you the slope of the function at a given point. All right, and that's one of the main things that we're going to be talking about. So if we have a function f of x, then we'll look at the derivative f prime of x right here to find the slope at that point. All right. So there's a bunch of properties of derivatives, and we'll expand on this. Trust me, we're going to be expanding on this in all the videos today. But for now, let's just start with that. The derivative is a slope. And remember, the slope of the graph is the slope of the tangent line. So all of this stuff is connected. But if you learn nothing else in this whole class, learn this. Derivative is slope. Derivative is rate of change. That'll come in later as well. All right, so let's look at some rules around here. So we got some properties coming up. So for f of x equals b. So this is a constant function, right? We know what constant functions look like. A constant function, maybe it looks like this. It's a flat function. So we know what the derivative of this is going to be because the derivative is slope. Any constant function is always flat. What's the slope of a flat function? 0. There is no slope. It's flat. Remember, if you have someone walking along here, they're walking on flat ground. There's no slope. So any constant function like this, the derivative will just be 0. So for f of x is equal to constant function, f prime of x is equal to 0. The slope, that's what f prime means, the slope at any point x is going to be 0. There's no slope, constant function. So that's our first one. If we have a line, f of x is equal to mx plus b, well, we know the slope of a line. You don't need calculus to answer this question. What is the slope of that line? Well, the slope of that line is m. And remember, the slope is the derivative. And again, it doesn't matter where you are on that line. No matter where you are on the line, the slope is always going to be the same, and it's going to be that m. All right. Now for the one that's a little trickier. This is our first rule. We're going to learn a lot of rules in this class, but most of the rules are way later in the semester. But the last thing you're going to have to remember about slope, and again, derivative, slope, almost interchangeable, is if I have any monomial x raised to the r power, any monomial, so yesterday in 1.2, we had x squared. We said the slope of x squared was 2x. Well, for any monomial, x squared, x cubed, x to the fourth, x to the fifth, and even some other weird things, the derivative is going to be r times x to the r minus 1. And this is what's known as the power rule. Okay? And essentially what happens is, so again, let's, these are all very, very important, but this last one specifically is what's known as the power rule. And essentially what's going on, right, is this exponent comes down in front, right? This r comes down in front. You take the power down, and then you subtract the power from the remaining. We're going to be using the power rule a ton. You might say, do I have to memorize the power rule? And I'm going to say yes, but it's going to be super easy to memorize this because we're just going to be using it so frequently. All right. So here we go. Let's get into some examples. Oh, sorry. One more thing. a notational comment is there are other ways of writing the slope. There are other ways of writing the derivative. Okay. So a lot of times we'll write f prime of x, the slope formula, the derivative for any x. What is the slope of the function at that place? But we can also write it in this form, d dx of f of x. So this is like it's called like the differential operator, essentially. I say essentially way too much, but this just means take the derivative of this function. Take the slope, find the slope of that function, okay? So these mean the same things. You can see this in other ways as well. Sometimes you're gonna see y prime. Sometimes you're gonna see dy dx. Very similar. These all mean the same thing. So just things to keep in wine. No, don't keep this in wine, okay? Things to keep in mind, just notationally. You're gonna see stuff like this. All right. So we're gonna do some problems right now. Okay. So example 1. Find the derivative. That's supposed to be a colon, goodness. Part A. F of x is equal to x squared. So we already said in the previous section that the slope function, which is the derivative, is equal to 2x here. But we're going to use the power rule. So remember, go back to your power rule. The power rule says that if you have x to the r, you bring the power down and subtract the power. Okay? The exponent comes out in front. And then the new exponent is 1 less than the previous one. So over here, right, f prime of x, our slope function, well, take the exponent down. So the 2 comes down. Whoa, that was the wrong button. The 2 comes down, and anyway. And then the new exponent, we have to subtract 1 from it. So the new exponent, well, 2 minus 1, that's just 1. X to the first power is just the same as x. We don't always write that first power. All right, and that's the power rule. You could do that with any exponent, really. Part B, let's do another one. F of x equals the 4th root of x. And you might stop me right there and say, whoa, Jason, there's no exponent here. This is a radical. This is a 4th root. How can we use the power rule? We don't have any tools. Well, remember your algebra, which is, again, the algebra is going to be the hardest thing in this whole class for most of you. Remember the algebra. Let's rewrite this function. Remember that this is equal to x to the 1/4 power. And now we have an exponent. Okay, so this is going to be hard to remember. So I'm going to go off to the side and just say, recall that if we have the nth root of x to the m power, that's equal to the x to the m over n. That's very important to remember. All right, so now we can take the derivative. We'll look at f prime of x, bring the exponent down. The exponent is 1/4. And now the new exponent is just the old exponent minus 1. So maybe you want to go off to the side, right? Maybe you want to go off to the side and say, okay, well, what is 1/4 minus 1? Well, 1 is 4/4. So we have 1/4 minus 4/4. That's negative 3/4. And I like to do things off to the side just so I don't have to write as much and it's a little cleaner for me. So we're going to have the derivative, the slope formula is 1/4 times x to the negative 3/4. And that's our answer here. And that's the power rule. So very important to remember this fact over here. And don't worry, we'll be using it a lot. So hopefully it'll make it easier to remember. I almost pause for any questions, but if you have questions, and you ask the video right now, the video is not going to respond, but you can send me questions via email, Canvas, Slack, etc. Right, last one for the video. Part C. Oh my word, we actually have roughly a 10-minute video. I'm so proud of myself. Part C, find the derivative of f of x is equal to 1 over x to the 5th. Oh my word. All right, penmanship is not working for me today. F of x is equal to 1 over x to the 5th. Now you might say, well, you just use the power rule. Bring down the 5, subtract 1, you have 1 over x to the 4th with a 5. No. Right? Power rule. Right? Is only for x to the r, not 1 over x to the r. So we have to rewrite this. So another thing you're going to have to remember from algebra is that 1 over x to the nth power is just x to the negative nth power. That's another really, really important thing to remember. And so again, just like before, we have to rewrite this. We're going to rewrite it with a negative exponent. Negative exponent means reciprocal. Flip it upside down. So by adding a negative to the exponent, we get the reciprocal of this. And if you flip this upside down, it's x to the 5 over 1. And then just have the negative with the exponent. So once we have it written in this form, we can now take the derivative. So we'll have f prime of x. Whoa! F prime of x is equal to, use the power rule. The exponent comes down. We have a negative 5. And our new exponent is the old exponent, minus 1. So we have negative 5. Oh, I almost dropped my negative again. That's going to be a real problem for me this semester. And subtract it. Well, negative 5 minus 1 is negative 6. And sometimes you want to keep your answer in this form. And it's a perfectly good answer. Sometimes you're going to want to write it back in this form up here. Okay? So another way that you could express your answer is just negative 5 over x to the 6th. And remember this exponent that we have right here. This exponent only applies to the x. It is not attached to the negative 5. If we had parentheses, then it would go to both. And then the 5 would go in the denominator. But because we don't have parentheses, the only thing that has a negative exponent is the x. So the x goes in the bottom, but the 5 stays in the top. And the negative can go out in front, it can go on the top, it can go on the bottom. You can put the negative wherever you want, but the front is most common. Sometimes this form will be more useful, sometimes this form will be more useful. We'll use both. All right, and that's the first video. So you can go ahead and get work started on those homework problems. I'm going to make an extra video with some more examples if you want them, and then we'll move on to new material in the videos after that. Good luck.